Okay, so the question was write down a polynomial of zeros at these points, right? Okay, well, easy to do. There's one, right? Are there any others? Actually, there's an infinite number of polynomials, because we can vertically stretch this thing, can't we? Okay? There are actually infinitely many such polynomials, such that this condition has. Because any vertical stretch leaves the zeros alone. Okay? Because when you vertically stretch, you move something that many times further from the x-axis. The zeros are on the x-axis. They don't move anywhere, right? And also, obviously, if I multiply this thing by 17, negative 3 is still going to give us a 0, negative 1 and 5 are still going to give us zeros, right? Doesn't matter what we multiply this thing by. Okay? Now, if we horizontally shift it, that changes the zeros, doesn't it? Because everything moves in the x direction, the zeros aren't going to be where they were. Okay? If we vertically shift it, well, the polynomial has this kind of shape, and it goes through the x-axis here. If we lift it up a little bit, it's going to go through the x-axis at different points, right? Okay? It'll be like this. Okay, well, the general shape of the polynomial is always going to be negative 5, negative 1, 3. General shape is always going to be the same. It's going to go through these 3 points, and the only thing you don't know is what's the scale of your y-axis. Okay? Because I haven't put a scale in my y-axis. My y-axis is about here. So if this mark here is 1, it's a perfectly good graph. If this mark is 10, it's still a perfectly good graph. Has the same shape. That's supposed to go through the zeros, and I kind of missed here and here. I came a little close to there. You understand what I'm supposed to have done, right? Okay? Because we did talk about that last time. People were not only missing zeros, but they come over here and miss this one completely by coming down and then wobbling around down here in the negative numbers, right? So, you know, that's a transitional phase. I think everybody's got that straight now. Okay? So we understand that the y-axis could be labeled anyway, and this would still represent a function with zeros at these 3 points, right? Okay? So, okay, well, if this is 10 here, what's it look like the y-intercept is? Again?
Negative 10.
Negative 10.
Huh?
It almost looks like negative 10 to me.
Yeah, but it's not quite that far. I'd say it's negative 8. Just being contrary, I don't want to use 10. Okay? So there's a question. What's the value of A if the y-intercept is negative 8? See if you can figure out how to answer that question.